The world has seven wonders, but each of us has a more impressive wonder: the brain. Whether an ordinary person or a great figure, each of our brains is the most complex structure ever known. It's composed of about 171 billion cells, more than half of which, 86 billion, are neurons. Each neuron on average has 7,000 synaptic connections with other neurons, creating a super complex network with about 62 trillion connections. The only structure comparable in complexity to the human brain is the universe. Despite only accounting for 2% of a person's weight, the brain uses up to 20% of the body's energy, around 20 watts, enough to light several LED bulbs. Thanks to the relentless progress of processor generations, humans are getting closer to simulating the human brain, or even surpassing it, at least in terms of numbers. In 2012, IBM, one of the world's largest and oldest technology corporations, simulated 530 billion neurons and 100 trillion synapses using the Sequoia supercomputer, the second most powerful in the world at the time. This simulation had over 6 times more neurons than your brain, but that doesn't mean it's 6 times smarter than you. Quite the opposite, IBM's 530 billion neuron brain consumed power equivalent to several apartment buildings or a small town, but ran 1,542 times slower than real time. This means if you told it a joke, the massive brain would laugh about 8 years later. A genius once said, "If the human brain were so simple that we could understand it, we would be so simple that we couldn't." This means if the human brain were simple enough to be understood, humans with that brain would become so simple that we couldn't understand our own brain. What would it be like if you and I each had 2 brains? No, I don't mean each person having 2 heads or 2 brains inside their skull. But wait, isn't our brain essentially 2 separate halves housed in one skull? True, no neuroscientist would agree that the 2 hemispheres of the human brain are separate and independent brains, but you have every reason to think so. Functionally, the brain seems to have specialization. While the left hemisphere is usually responsible for language, logic, and analytical thinking, the right hemisphere is associated with creativity, imagination, and art. In fact, the 2 hemispheres of the human brain are not independent. They are physically connected by a long band of nerve fibers called the corpus callosum. The corpus callosum is the largest white matter structure in the human brain, containing about 200 to 300 million axonal projections and is about 10 centimeters long. If the brain is a machine with 2 left and right halves, then the corpus callosum is a cable of 200 to 300 million fibers connecting those halves. The axons are the long extensions of neurons, so the corpus callosum is the cable connecting the 2 hemispheres, allowing them to share information and coordinate activities. But have you ever wondered what would happen if we cut the corpus callosum, permanently splitting the 2 halves of the brain? A person without a corpus callosum or with a severed corpus callosum can still function normally, right? Ultimately, can the 2 halves of the brain, when separated, function as separate and independent brains? First, cutting the corpus callosum is not life-threatening. The corpus callosum lies deep in the brain beneath the cerebral cortex, so the only way for it to be severed without killing a person is during surgery. Corpus callosotomy is often performed to treat severe epilepsy. Epilepsy is a chronic disease causing recurrent seizures in both children and adults. The corpus callosum is the information bridge between the 2 halves of the brain, and this information includes seizure signals of epilepsy. A seizure starting in the left brain theoretically only causes seizures on the right side of the body, as the left side of the body is controlled by the right brain, and vice versa. This is called the lateralization of brain function. But thanks to the corpus callosum, the seizure signal spreads to the right brain and causes seizures on the other half. In principle, severing the corpus callosum, or brain separation, doesn't cure epilepsy but limits its harm by isolating the seizure signal to the hemisphere where it starts.